I am going to discuss the codes for this GUI figure. So first, these radio buttons should have a tag, and I labeled it as radio 1, radio 2, radio 3, radio 4, and radio B radio 1, B radio 2. So the only object here with a code are the push buttons for convolution, autocorrelation, and cross correlation. And the static text has a tag of answer. Let's go to the code for the convolution. So I have the variables here to get the handles of this radio button. If they are selected, these variables will get the value of that radio button, so that if B is 1 or B is selected, and if C is selected, C stands for this one and B stands for this one, so that U and V, we have the inputs, and using conv of U and V, which stands for convolution, and it will set the handles of the static text to W. Same thing with C2, and the C2 is 1, 3, and 0. It will also set the answer in static text. So these codes are just repeated. These codes repeat with itself. It's just that the value for the inputs vary, and next we have the autocorrelation, and this radio button has a tag of radio 1. So this is very short. I have here B to get the value of the radio button, and since the autocorrelation is similar to convolution, it's just that the V is a mirrored value of the U or the X of N, meaning the V here is X of negative N, and I get the convolution of U and B, and it will set the answer to the static text. Same here, the n equals 0 is at the first, which is also equal to 5, meaning the n equals 0 at the output is at the middle. And then for the cross correlation, the B here will get the value for the radio button of 3344, and the C will also do the same to 687, so that if B is equal to 1 and C is equal to 1, it will get the X correlation or cross correlation of U and B, and it will set the answer to the static text. And that's all for the coding of the program. After simulating the program, we will test the convolution and correlation of these inputs. For example, we have this x1 and this x sub 2. The convolution is this, and for another input we will have this convolution. It will also work with other x sub 1 and other x sub 2. Now the n equals 0 is always at the first value, meaning the 0 starts from -3, 0, 1, -2. And for x sub 2, the n equals 0 is always at the last value. In this example, the n equals 0 is at the -6 and 0, meaning if we have this output, the n equals 0 is always at the middle. In this case, the n equals 0 is -19. And for the correlation, I have here the two types, which are the autocorrelation and the cross-correlation. For autocorrelation, the output should be RXX. If I have value of input xn, which is 5, 6, 8, and 4, if I get the autocorrelation, the answer is this. And since this is the input, the n equals 0 starts from 5, so that the n equals 0 for the output is in the middle, which is also 141. Next, for the cross correlation, this correlation given are from the assignment number 6. So for the cross correlation of 3, 3, 4, 4 for xn and 6, 8, 7 for yn, cross correlation is this. This should be equal to 0, but since the n equals 0 starts from 3 and the n equals 0 also starts from 6 for the yn, this means the n equals 0 at the output should be in the middle, which is also 70. So this is the initial value for n equals 0.